Yes? Isn't it? Yeah, it says it on there. You got to look for it. Right? Now, if you recall, on all these cliff problems where you know the height of the cliff, what we do is we use x is VIT plus 1/2 AT squared. Right? That's all we do. Is we do this, right? Remember that the initial velocity on this one is 0, and so it ends up being something like minus 100 equals 1/2 negative 9.8 t squared. Can't you solve that for t? Yeah, okay. So you're going to get the t. The t is going to go across. And then how do you find out that velocity? Yeah, you put it in the formula. You actually use the same exact formula, only different things drop out, right? So x is VIT plus 1/2 AT squared. Only now the a is 0, so this goes away, right? Ta-da. Okay. So you're going to solve it that way. Yes, we've done cliff problems. Haven't we solved? By this point in your career, I think you've solved 5 of them at least. Yes? I did an example. You did one on your own. You did 3 book problems, right? We're going to be so good at these, right? So that's what you do. That's what we're going to see. I'll know that you're successful when you've actually calculated what this time is. Okay? Well, you know, this is how I grade these. You can't have done that if you don't know what that time is. So there it is, right? Okay, so that's challenge 1. Then I want you to do the next thing. I think the next thing to do is challenge 8. Sorry. And then challenge 3 is the last one. So challenge 8 is, very advanced. Okay? So let's go out. I'm going to escape X to the main menu. You got to type the keystroke there. And then challenge 8 is the letter H. It's a cliff with a moving target. So now there's this, watch, I'm going to go 0 angle, 25, watch the target. This is amazing. Okay? This is what computers can do. Computers can make things move on the screen. So watch that target. Are you ready for this? Watch. Did you see it animate that little rectangle? It was amazing. I'm going to do it again. Watch again. Like we keep missing it, right? There it goes, right?
So you
okay.
Gotta freaking fire that thing.
Yeah, Morgan's got a question. I didn't choose it. That was the default value, and it never hits.
All you do is press the letter of it, and then it will know what you're doing.
Oh, you mean how did I get to this challenge?
I just don't understand.
Okay, here. Here's how I got to the challenge. Was you can type the letters, right? So F, G, H. You can also use up and down arrows. Yes?
Yeah.
Okay, then once you're in there, it just gives you some default value. It's never the right one. Okay?
Right, like.
You got to calculate it. That's the whole point.
Right one for what? Am I trying? Oh,
So.
okay, sorry. It just takes me a minute.
Okay, so. Read the directions. You got to read them. Okay, so see how the directions are up there?
Has a different
Yeah.
meters or whatever?
Yeah.
Okay.
Yeah. Now, let me talk you through this because there's easy ways to do this and there's hard ways. Easy ways and hard ways. Okay? Well, the hard way is the way we did it for years, and then some kid came along and like rocked our world, so I'll tell you both stories, right? The hard way is this. You can't launch for 100 meters, right? I can't launch for 100 meters. If I hit it 100 meters, then I'll miss it because it won't be there anymore, correct? It'll have something like 4.5 seconds or so to get away, yeah? Is how long it takes to fall 100 meters, right? So what do I got to do? I can't launch for where it is now. I've got to launch for where it's going to be. So where's it going to be?
150.
Yeah, it's going to be somewhere about 150-ish or so, right? Now we can be more exact than that because don't we know the time it takes the projectile to hit the target? Yeah, we know it's going to be whatever that time is, right? It always is that much time, regardless of how far out it goes. Remember that whole thing? The cannonball shot out a mile lands at the same time as the one dropped, yes? Do you remember that? Yeah. You got to believe it. Okay, so we always know the time. With the time, can't we figure out where it's going to be? Yeah, it goes this way, right? You start at 100, you move 10 meters every second. So if it takes 3 seconds for you to hit the target, you're going to move 30 meters beyond 100. Yeah? You're going to be at 130. If it takes 5 seconds for you to hit the target, you're going to be right at 150, aren't you? Does this make sense? Yeah. Okay, so that's way number 1 is predict where it's going to be, step 1. Step 2, have the target, have the thing launch for where it is, for where it's going to be. Now, here's the second way to do it, and I thought this was a slick way. I asked some kid, I said, how'd you hit it? one time. This is like 5 years ago. And he said this. He goes, well, here's what I did. I launched for where it is now, and then I added 10. Does that work?
Yeah.
Well, I didn't think so. So I said, no, that doesn't work. You can't do it that way. You've got to do it this way. So he did it that way and got exactly the same number. You know, you can do that. So that's the second exciting way, is launch for where it is. You already know how to do this. It's exactly the same thing as this, only make the range 100, right? And then just add the velocity of the target. Works every time. Why does that work? I'll leave you guys are so talented and gifted. I'll let you guys figure out why it works. I have an idea in my mind why it works. Okay? But anyway, that will always work. So that's challenge 8. And then challenge 3 is just simply this stuff that we've done. So you're going to be doing, please don't set up the horizontal vertical table for challenge 3. Please do use the range equations, okay, to solve number 3 in the way that I showed you, okay? Say it again. Yeah. Challenge 8 is the moving target one. Yeah. Are we good on this? Let me show you the demonstration, and then you guys can go and work on that. But first I have to do a demonstration.